In this video, I'm going to prove the formula for the sum of squares with cubes. Let's start. All we need is a cube with side length 1. That means its volume is also 1. Now here's the idea. Let's look at the sum of squares from 1 to 10, but instead of adding numbers, we will count using cubes. So we have 1 squared, 1 cube, 2 squared, 4 cubes, 3 squared, 9 cubes, 16 cubes, 25 cubes, 36, 49, 64, 81, and finally 100 cubes for the 10 squared. If we stack them layer by layer, we get a pretty interesting shape. And this shape looks oddly familiar. It's kind of a pyramid. Now, we know the formula for the volume of a pyramid. And here's the cool part, since each cube has volume 1, the total volume of our stack is the sum we are trying to calculate. So the real question is, how do we find the volume of this shape? Our shape looks like a real pyramid, but it's missing a few things, and that's the key. To turn it into a proper pyramid, we'll need to add a few parts: the top, the corners, and the edges. The very top of the pyramid, that's just a small pyramid by itself, with volume 1/3. Next, for the edges, each layer has 4 edges, and if we add them all, they simplify to a Gaussian sum. Now for the corners, on each layer there are 4 corners. The volume of each corner is 1/12, so 4 of them make 1/3. And stick with me, all of this will make sense. And since we have 10 layers, that's a total of 10 divided by 3 from the corners. So let's put it all together. The volume of the full pyramid, it's 11 to the 3rd power divided by 3. But to get the volume of our shape, we have to subtract the parts we spoke earlier, and that is the top, the corners, and the edges. Stick with me, this will make sense in a moment. If we generalize, instead of 10 we use the variable h for height, we get this. And after simplifying, we get exactly the formula for the sum of squares. But this kind of geometric reasoning works great for squares. But once you move to cubes, 4th powers, or anything higher, things get weird. You would need to start thinking in higher dimension space, which is another topic.